uses stoichiometric calculations from a measured mass of a reagent. Okay, did you get all that?
Measure mass from.
Of a reagent. It's like James Bond wasn't an agent and then he is reagent.
You get rid of that chair. I keep thinking going on.
Well, gotta do what you gotta do. Okay, generally, in a gravimetric analysis experiment, you are trying to determine the mass of the precipitate. The T-E at the end. A precipitation occurs when a reaction forms a slightly soluble compound. Product, let's say product. Slightly soluble product. In quantitative analysis involving precipitation, the sample solution, so the sample solution is combined with an excess quantity of another reagent to ensure all the sample reacts. This is extremely important that you know and remember and have that known and remembered. Very important. So, to do this analysis, you take a limited sample, you add an excess of whatever reacts with it, and then you get your precipitate. So your goal in these types of questions is to find the mass of the precipitate to then determine the mass of the sample solution. That's kind of the overall goal with this application of Grav Stoich. So if we are to kind of summarize that into a chemical formula, what you think is, okay, I have a limiting reagent, so reagent, which we're going to say this is the sample, okay, plus an excess reagent that will form a precipitate which we will weigh. You actually measure the mass and other solution, because it will be a double replacement reaction, and so you'll obviously have another solution left over. So for these questions, what it's focused on is, say you have a question that's how much, or like what is the mass of the dissolved stuff in this solution. So for example, I have two solutions here. One is calcium chloride. I know like how much is in the here. And here is sodium carbonate. Say you don't know the concentration of this. Okay, you don't know what its concentration is. You don't know how strong it is. You don't know anything about it. All you know is that it's sodium carbonate. How could you find out? Well, this is how you find out. You add something to it that will make a precipitate. If all of that stuff gets precipitated out, then you can solve for it. So let's actually do a practice question, and then I will go into like all of the lab details of how to do it. You know your reaction is complete when combining the two solutions stops producing a precipitate, so there's no more cloudiness. Then you need to collect, dry, and measure the precipitate. So I'll tell you how to do that in detail, but first let's go to the practice question, and just so that you have an idea of kind of what kind of the big picture is with these questions. So a student is given the problem to precipitate out the carbonate ions. Okay, you finish reading it and make a chemical formula with those two reactants. So I'll start this with the girls, and then when you guys come back, they're gonna go, and then I'll do it with you. Okay? Okay. So let's write out our chemical formula. So basically, what we're reacting here is we are going to make this is like one of our reactants. They choose to use an excess of calcium chloride in solution. So it's like, this is the sample, and this is the excess. And you're gonna make a precipitate. So let's write it out. We have sodium carbonate plus calcium chloride. I'm just going to rewrite it so that's not so big. And it goes into a double replacement reaction. So both of these are aqueous. Now calcium carbonate is a solid, which makes sense because any shellfish, any animals that live in the sea that have shells, it's made of calcium carbonate. Yeah. So in geology, when you have rock that has a lot of calcium carbonate, it's probably from like oceanic type of rock or rock that's close to the ocean. Cool fact, hey? Okay, and sodium chloride, that's definitely aqueous. So balancing this, you just have to put a 2 in front of here. Okay, so the student chooses to use an excess calcium chloride, and we want to precipitate out our carbonate ions. Okay, so what minimum mass of calcium chloride is needed to react all of the excess, or all of the sodium carbonate? So this is like our wanted. This is what we're trying to find. Okay, and what we are given is information about our sodium carbonate. So are we So your N is equal to your C times V. So N is 0.05 moles. So it's, just a basic Stoich kind of comparison. So it's a 1-to-1 ratio. So here, I need, in order to react this much amount of my sodium carbonate, I will need the same amount of moles, because it's 1-to-1. What's my molar mass for calcium chloride? 110.9. So what's my mass then?
$5.549.
5.549. Okay, so if we put that to sig digs, then that's 5.5. So it's still just kind of normal Stoich questions. We're just putting it into kind of a bit of a different context here. Okay, so we'll do another one. So now we can do this experimentally, and we measure out this precipitate. So in order to find a precipitate, we need to filter it. So I'll just show you. Well, I'm going to do it without the boys. So let's just jump to here, this demo. It says, oh, and they're done.